Thank you for share, Professor Otto. Uh, gentlemen, good afternoon. It's my great honor to share our recent work. Uh, Now, the previous title is still ongoing, so I changed the title, just rename the Facet characteristics, and it is lowered in very high cycle fatigue and compared the conventional and additively manufactured mechanical materials. This is the outline. One point is the facet in titanium alloy, and the other is facet in nickel-based alloy. Some of these results have been published in MSEA to MSEA paper, and one is prepared to be submitted to IFTIG. It is well known for failure analysis. Flactography is the one of the important approach, and the other one is the SN curve, based Waller's strength to determine fatigue strength and fatigue limit to predict the life and the performance. The other method is the DADN curve to measure the fatigue growth, and then the fluctuate surface is used to develop and evaluate the theoretical model of crack growth behavior depend on the detail fluctuate surface. So that is very important. The other aim is to summarize the typical feature, just like the facet, the topic of facet. What is the facet? Exactly, facet is a very ambiguous notion, just like this. These two figures is the fluctuate surface in titanium alloy with bimodal microstructure. The facet is seen regarded as relatively smooth plane like this and like this, smooth plane. Quite smooth, but then the notion is not well defined. So I will talk show some examples in titanium alloys. Titanium alloy is well known. Titanium alloy have solid phase transformation in the room temperature in the alpha phase. HCP alpha phase is quite regarded brighter, and in high temperature it's beta phase means PCC structure. So depending on the morphology and distribution of this form. This form is the optical images of titanium alloy. Depend on this white region is the alpha phase, and then this green region is the beta phase. Depend on the alpha phase, the shape and distribution, we can define the equiaxial microstructure like the figure A, and both equiaxial alpha phase and this laminar microstructure called bimodal microstructure. Equiaxial microstructure and bimodal microstructure is the most useful to measure titanium alloy, and the other we call the laminar microstructure, or depend on the forging process. Like this, nice the laminar microstructure, also called so-called basket wave microstructure. And this figure is the titanium fluctuate surface of titanium alloy with equiaxial microstructure. This one is for the low cycle and not very high, just in high cycle fatigue. This is quite low. You can find the fluctuate surface just for like this. We cannot determine the specific crack originals. And this figure is easy to find. Easy to find the granular region, granular fluctuate surface, just like this. This region means crack initiation region. We call RA, rough area. And this specimen failed in very high cycle fatigue. These two samples just under -1 stress ratio means symmetric push and pull. And this one also show the equiaxial microstructure, but the stress ratio is the 0.5. 0.5 means tension loading when high cycle fatigue. This also show it very clearly. Correct the illustration region is easy to find the very small the frame, and this just show the real pattern fluctuate surface means so-called facet, just the topic to discuss. And this figure, these two figures also show the interior fluctuate surface region. You can easily find the correct illustration region. But these two specimens, these two fluctuate surface belong to the other specimen means called bimodal microstructure. Bimodal microstructure just a mixture of equiaxial alpha and laminar microstructure domains. It is easy to find in the when the stress ratio equals -1, it's only in the granular surface. It didn't find the fluctuate surface like this facet. But in this figure, the facet number, you can compare the whole correct illustration region. The facet number is not very enough compared to this one because the equiaxial microstructure is limited. This story figure just for the other titanium alloy. This titanium alloy microstructure just show the cost laminar microstructure cluster and 5 equiaxial microstructure matrix. It is easy to find. This figure is for -1 stress ratio and in high cycle fatigue regime. It's easy to find this region. This region also can be regarded as facet. So the facet, the definition of facet is quite ambiguous. This one also can see, but it is called big facet. This facet, we use the TM, Faber and TM. We can determine this region just under this region is a big cost laminar microstructure cluster. But in this one show the other microstructure just under this facet. And this fluctuate surface for the other specimen, the specimen under the stress ratio 0.5 and also failed in very high cycle fatigue regime issue diverse morphology of facet. It is easy in the laminar facet. The laminar facet also show this morphology. Just like this, this one and this one. The under the fluctuate surface is also the laminar microstructure or equiaxial microstructure. So the conclusion is the facet morphology is quite different. So the previous definitions are quite ambiguous. So we talk the facet is easy to find. The facet formation consume cellular very high cycle fatigue strength is easy to find. This is a half diagram showing in the strength and 1 billion cycles. This curve is for the bimodal microstructure titanium. This curve for the laminar microstructure. This is our fated glue. Our fated equation just show from the equiaxial microstructure. It is easy to find the bimodal microstructure is a combination of the EM and the LM. The LM just show the Gerber defect, so it's insensitive to the tensile mean stress, but the equiaxial microstructure is very easy to affect by the tensile mean stress. The other result we still ongoing is about the facet in nickel-based alloy. We use the PBF powder bed fusion and this nickel chromium and the ferrite. This is the heat trade uh, strategy. We use the solid solution and double aging. So we obtain this tensile curve. Is very good tensile strength, and the ductility can be still usable. Let's show the microstructure. The microstructure in nickel-based alloy in additively manufactured just to show the metal pool microstructure. This enlarged green just the FCC nickel-based gamma green in this enlarged one, and we also can find the pore defector in this, and in the enlarged optical microstructure, it's easy to find the precipitators. It's very this figure show the SN curve. SN curve. This figure show the typical fracture surface under optical microstructure. It's easy to find the dark region. The dark region it means the crack initiation region. This small one just the very large for the stress ratio 0.5, and the flag initiation region still in the specimen surface and for the -1. So under the higher magnification, you can see this one the surface induced fatigue failure. You can easily find the quasi-facet and the stability trace in the crack initiation region. And for this -1, this 0.5 stress ratio specimen field one, it is easy to find this microstructure also from the specimen surface. This one is for the also for the 0.5, but then this one is in the high cycle fatigue region. This is for very high cycle fatigue to find the facet. The facet is easy to find, and then the facet with the slip trace. It is not like the facet in equiaxial microstructure, the titanium alloy. Now, this figure also show this is the specimen field in -1, -1 in when I have cycle fatigue regime. It is easy to find. Not only in the fracture, the rough area, but we didn't find any facet morphology in this case. And this case it show interesting phenomena just in the facet and slip phase in both subsurface crack initiation and in the interior fatigue crack initiation region. It's easy to see the facet morphology and slip trace. And we also talk the tensile mean stress effect on the incolor alloy. It is defined at 1 million cycles, and almost obey the Goodman line. And with the fatigue life increase, the fatigue resistance just tend to around our group, our proposed model, just like this. So the facet formation it is very strongly deteriorate the fatigue resistance in very high cycle fatigue regime. That is the main conclusion. I hope to stop in here. And as a propaganda, I believe you have a special issue about fatigue and fracture of crystal metal structure or submission is welcome. And thank you. Thank you.